So today I am going to discuss about the module 1 of electrical engineering subject. So that is network elements and laws. So the contents in the first module, that is the basic concepts of circuits, basic definitions, and Ohm's law, Kirchhoff laws, dependent and independent sources, passive elements like resistor, inductor, and capacitor, and energy stored in inductance and capacitance, and circuit analysis like source transformation, star to delta transformation, node voltage method, mesh current method, including the super node and super mesh analysis. So that these are the contents that we are going to see in the module 1 of network elements and laws. So today's class we are going to discuss about that introduction. So what is the voltage and what is current and what is energy, what is power, and what are the relationship between the voltage, current, and power and energy. So what is meant by, so in generally we can see that the circuit means what. So circuit is it is consisting of many energy sources and the also number of electrical parameters. The electrical parameters we can say that the resistor, inductor, and capacitor. So they are connected in different fashion, the different ways, like in star connection, delta connection, series connection, or parallel connection. So depending upon the connection, we can say that the circuit can be consisting of more than one or more energy sources, as well as the number of electrical parameters also. So the different electrical parameters are resistor, inductor, and capacitor. Just now I said. So that is the different electrical parameters are resistor, inductor, and capacitor. So the combination of such elements along with various sources of energy gives rise to complicated electrical circuits, generally referred as network elements, generally referred as networks. So here we can see that the terms, the network and the circuit, these are the synonymously we can call as in electrical literature, the electrical circuit as well as the network. We can say both. So circuit may or network, we can say anything. So, okay, so the network is nothing but the interconnection of energy sources and the energy parameter and the circuit parameters, electrical parameters. So that is about the network and circuit. So here is simply way we can say that the circuit may be consisting of the three components here, three major parts. So first one is the energy source. So the energy source may be AC or DC. Okay, so that we will discuss this energy sources also. We can say that battery also, we can say one battery also. So these are the energy sources, or we can say generators. So these are connected to the lamp or motor by means of a connecting wires. So then we can call it as that is complete one circuit, simply an electrical circuit. So that means here you have to connect a battery here, and we have connected this battery to a generally we can say that load. So the load may be bulb, or the load may be motor. Load may be motor. So this connection we can call it as completely, we can say that electrical circuit. So the purpose of circuit is what? What is the purpose of the circuit? So the purpose of the electrical circuit is to transfer the energy from source to load. So the source may be your battery or alternating voltage source or direct current source. So that whatever the energy is there, so that is supplied or that is transferred to the lamp or load. So that is the main purpose of a circuit. So this accomplished by the passage of electrons through the wire around the circuit. So without these electrons, the energy is not transferred. That is, it is a passage of electrons, and the energy has to be transferred from one place to another place. So with the help of battery, and that transferred energy is connected to lamp or load. So more specifically speaking, so the interconnection of two or more simple circuit elements, which is voltage sources, resistor, inductor and capacitor, all called as electrical network. So that is the main definition of electrical network. So what is the definition? Means here, the interconnection of two or more simple circuit elements. Two or more simple circuit elements. So which is connected voltage source, resistor, inductor and capacitor is called an electrical network. Next. So that is about the definition of electrical circuit or electrical network. So next we will see the definition of voltage. So here the voltage, simply we can say that according to the structure of an atom, we know that there are two types of charges. One is positive charge and another one is negative charge. So a force exists between these two charges, positive charge and negative charges. Certain amount of energy or work is required to overcome the force and move the charges to the specified distance. That means here, in simply way, we can say that a voltage is nothing but it is a we have to transfer the charge from one place to another place. Certain amount of energy is required. So that energy, we can simply say that force. Okay, certain amount of energy is required. So that to overcome this force, so and move the charge to a specified distance, we have to require some energy. So all opposite charges possess a certain amount of potential energy because the separation between them. All positive charges possesses, opposite charges possesses a certain amount of potential energy because the separation between them. So difference in potential energy of a charges is called potential difference. See here, we can say that voltage, in terms of potential difference. So the difference in potential's energy of the charges is called as a potential difference. So potential difference in electrical terminology is known as voltage. The potential difference means we can see here if the two charges are the positive charge and negative charge is there. So here, if the positive charges are there and negative charges are there, so they have to repel, they have to attract each other. The force will be exist between them. So here, the difference of potential energy of charges is called as a potential difference. So it is denoted by either capital V or small v, potential difference. So potential difference in electrical terminology we can say it as voltage. So it is expressed in terms of energy per unit charge. Energy per unit charge. So that is the voltage we can express it as V equals to W by Q. That means here, so the amount of energy required to move the charge from one place to another place. To move the charge from one place to another place. So then we can set that as voltage. So that is simply says that voltage is nothing but it is the amount of energy required to move the charge from one place to another place. So it is, we can call it as a voltage. So in another way we can say that that is V is equals to dW divided by dQ, where W is the energy and Q is the charge. So the units for the energy is joules and the units for the charge is coulombs. So simply says that joules per coulomb, or we can say that volts. So here dW is nothing but the small change in the energy and it can be expressed in joules, and dQ is nothing but the small change in the charge and it is expressed in coulombs. So the generally voltage we can be expressed in volts. So therefore voltage we can express it in volts. So simply says that V is nothing but dW divided by dQ. The amount of charge required, the amount of energy required to move the charge from one place to another place. So that we can call it as a, simply says that it is a potential difference or voltage. Next, coming to the next definition, that is current. So current is nothing but the free movement of electrons. So there are free electrons available in a semiconductor or conducting materials. So these free electrons move at randomly in all directions with the structure in the absence of external pressure or voltage. See, whenever we are not applying any external pressure or voltage, so there are free electrons are available in the semiconductor or conducting material. So these free electrons move randomly in all the directions within the structure. If certain amount of voltage is applied across the material, then all the free electrons move in one direction depending upon the polarity and applied voltage. So depending upon the polarity and applied voltage, so all the free electrons are move in one direction. So the movement of electrons from one end of the material to the other end constitute an electric current. So the movement of electrons from one end to the material and the other end of the material constitute an electric current, and it is denoted by capital I or small I. So in other words, we can say that current I is equals to dq divided by dt. That is amount of charge is required. That is rate of flow of electrons or rate of flow of charge. And the units for this one is coulombs per second. The units for this current is coulombs per second or amperes. So simply says that the current is nothing but the rate of change of charge. That is current I equals to dq divided by dt. So this is about the current. Next one we will discuss about, next one is power and energy. So energy is nothing but the capacity for doing work, and energy is nothing but the stored work. Energy is nothing but the stored work. Energy may exist in many forms such as mechanical, chemical and so on. So energy neither can be created nor can be destroyed. So it can be only transformed from one form to another form. So the energy may be in the form of mechanical, chemical or so on. So power is the rate of change of energy. Power is the rate of change of energy, and it is denoted by capital P or small p. So that is that P is equals to rate of change of energy. So energy we can represent in W. Energy we can represent in W, and time T is time is in second. So energy can be measured in joules and time can be measured in seconds. So joules per second. So we can simply say that it is a watt. So the power can be represented as, that is P is equals to dW by dt. That is the rate of change of energy, and it is denoted by either capital P or P. So that that dP by dW by dt, so I can write in the two ways here. So that is the P is equals to dW by dt. So this I can written in two ways, that is dW divided by dq into dq divided by dt. So the product of this, so the dW by dq is nothing but the voltage, and dq by dt is nothing but the current. So simply says that the power P is equals to the product of voltage and current. Simply say that with this VI. So we can measure this in watts. We can measure the power in watts. Similarly, we can measure the energy in kilowatt hours. So that energy we can measure, that is the integration of power over a period of time. So the units of this one is watt hours. The power can be measured in watts and time can be measured in watts. So the energy we can measure in watt hours. So this is about the voltage, current, power and energy. Next one, we will discuss about the different types of elements which we are going to see the electrical network concepts. So the first elements, we can say that linear and non-linear elements. And second one is active and passive elements. And third one is unilateral and bilateral elements. And fourth one is time variant and time invariant elements. So now let us discuss these four types of elements one by one now. The first one is linear and non-linear elements. So what is meant by linear and what is meant by non-linear elements? So here, according to the definition is saying here, element is said to be linear if its VI, that is volt ampere characteristics, follows only one equation of the straight line or Ohm's law and passing through origin, then we can say that as this is a linear elements. The example for the linear elements are resistor, inductor, capacitor are considered as linear elements. So these linear elements possesses their linear relationship, that is their if it there follows the VI characteristics and they have follow only one equation and they have follow the Ohm's law and they are passing through the origin. So then we can say that elements as a linear elements. So the characteristics of the linear elements we can see here. So here if you can observe this VI characteristics, so here the VI characteristics, it is having only one, we can say that one equations it will follows and it will follow Ohm's law and it is passing through the origin. Similarly in this diagram also, so these are the characteristics of linear elements. Okay, linear means what here? They have to follow the VI characteristics and only one equations of the straight line and it will follows Ohm's law and it is the whatever the equation is there, it is passing through the origin. So next one, non-linear elements. So an element is said to be non-linear if it is VI characteristics are not follow the only one equation. If it is not follows the only one equation and not follow the Ohm's law, very very important point here. So if the element is not follows the Ohm's law, then we can say that is non-linear elements. The best example for non-linear elements is diode, BJT, JFET, SCR, that is silicon control rectifier, are considered as non-linear elements. If we can observe the VI characteristics of a diode, so then we can say that the characteristics are not linear like this. So these are the volt ampere characteristics of a diode. Similarly, we can see for the SCR characteristics also. So SCR characteristics also, it is non-linear. So these are the SCR characteristics, volt ampere characteristics of SCR. So by observing these two characteristics, we can say that the diode, BJT and JFET SCR are non-linear elements because they are not following the Ohm's law and they are not following the VI characteristics and they are not following the one equation here. So then such a type of elements we can call as a non-linear elements, and the characteristics of the non-linear characteristics we can see here. Okay. So that is about the linear and non-linear. Linear elements means simply says that which will follows the Ohm's law and the equations are passing through the origin and the VI characteristics are linear. So here the VI characteristics are non-linear, it will not follow the Ohm's law So then we can say that it is a non-linear elements. Next, coming to the second one, that is active elements and passive elements. So what is meant by active elements or components? What is meant by active elements or components? So here an electric circuit or electric circuit element which can supply electric power to the circuit or power gain in the circuit is known as active element or active component. So that means here active means what? Here we have to, active means it has to supply the electrical power to the electrical circuit, or power gain in the circuit is known as active element or active component. Some common examples of active circuit elements are energy sources, so that are voltage source and current sources are the common examples of active circuit elements. Similarly, generator or alternator, semiconductor devices such as transistors, photodiodes, etc. And the active elements are the circuit components which are entirely responsible for the flow of electric current in the circuit. So these are the active elements or active components. So the components which have to supply the, or which are entirely responsible for the flow of electric current in the circuit. Okay. So that is about the active components. So let us see the example of the active components. So generator, battery, transistor. So these are the examples of active components. So these are supplying the energy to the load. These are the active components. Next one, what is passive component? So the circuit element which can only absorb electrical energy and dissipate it in the form of heat, or stores either in magnetic field or electric field, is known as passive component circuit. So that means passive means what? Passive means they have to consume the energy, or they have to store the energy in the form of magnetic field or in the form of static field or electric field. Simply says that we can say that the passive components. The example for the passive components are resistor, inductor and capacitor, and a transformer, etc. You can see here the figure shows here the passive components. So the passive components are the resistor, so it will consume the energy and it will absorb and dissipates the heat in the form of and the capacitor will stores the energy, and the inductor is also stores the energy in the form of magnetic field, and the inductor will stores the energy in the form of static field. Okay, so therefore passive components cannot provide electric power or power amplification in electrical circuits. So because of the above reason, so the passive components cannot provide electrical power to or power amplification in an electric circuit. Some common examples of passive circuit components are resistor, inductor, capacitor and transformer. So this is about the what is a passive component. So passive components are completed. Next one is the unilateral and bilateral elements. So what is meant by unilateral? So an element is said to be unilateral if the element is following the current through the element. If the flowing of current through the element is only one direction, or current flows through it due to the majority carriers only. So what is unilateral? Unilateral means if the flowing of current through the element is only one direction. Okay, so let us take one simple resistor here. So the current flows in this resistor only in one direction, not in both directions. Then we can set that element as unilateral element. And the constant current and voltage sources are the examples. Constant current and constant voltage sources are the examples of the unilateral elements. diode, FET, BJT, etc. are the examples of unilateral elements. Unilateral means the current flow movement is only in one direction. Similarly, second one, the elements which are said to be bilateral, if the same impedance it offers the same impedance characteristics. So that is resistor, inductor, capacitor is an example for bilateral elements. Bilateral elements. So that means here the current flows in both the directions. For example, if you can say resistor, in the resistor the current may enters in this port, in this network, or the current enters here. So in the both the directions the current will be enters. Then we can say that it is a bilateral network. Bilateral network, and the elements are resistor, inductor and capacitor are the best example for the bilateral elements, and each linear element is bilateral in the nature. So that is a point. Okay, so next one, time variant and time invariant elements. So what is meant by time variant elements? Time variant means the elements, the behavior of the elements are changing with respect to time. So element is said to be time variant if the VI characteristics are changing with the time. Otherwise it is time invariant. So whatever the characteristics, we can see the volt amperes relation for resistor, inductor and capacitor. So they are changing with respect to time, then we can say that as a time variant elements. If they are not changing with respect to time, then we can say that it is a time invariant elements. Okay. So that's all for now today. So next class we will continue. So thank you for watching.